important. Okay, when you have redox reactions, this is all revision still for AS. Primary alcohols, they would get oxidized to aldehydes and then carboxylic acids, and then you'll have secondary alcohols turning into ketones. And then you will have tertiary alcohols that would not get oxidized at all. So aldehydes would get oxidized to carboxylic acid using all these reagents. So the first thing was that if you're given a molecule, you need to identify what type of alcohol it is. So, for example, if I draw a molecule and it's got I mean, remember, this is not benzene. Benzene has this is a normal cyclic compound. So let's say there is this molecule and it's got an OH group. There is an OH, there's an OH group over here as well. And there's an OH group over here on this side. So it's got 3 OH groups. So which one will this be? Is this a primary alcohol or is it a secondary alcohol? क्या होगा Saim? What is this one?
So primary होगा क्योंकि no other carbon attached to it.
Okay, there's I mean, on this carbon atom there's only one side. There's only one carbon chain. So this one is primary. Okay, what is this one? The other one? This one over here. Which one is this one?
So this is also primary.
See, it's attached to a carbon which is bonded to how many chains? It's bonded to 3 chains.
So it's secondary.
Tertiary, it's bonded to 3 chains.
Oh.
But 3 chains, there's 3 chains around it. Okay? I mean, this carbon atom, so you have to focus on the carbon atom. The first one was only bonded to just this one was only bonded to a carbon atom that had only 1 carbon chain. This one is bonded to a carbon that's bonded to 3 carbon chains. So this one is tertiary. So Zahib, iska bata do, what is this one? The OH over here. What is that?
Secondary.
Secondary.
See, that's right. That's secondary. So, anyways, that's the first thing. You have to identify which one is primary, which one is tertiary, which one is secondary. So let's assume that the oxidation is complete. So primary would turn into carboxylic acid, secondary alcohols would turn into ketones. And remember, the only change that would be happening to that carbon atom. The rest of the molecule would remain exactly the same. So that carbon atom would turn into carboxylic acid. Secondary alcohols, this one, the secondary ones, they would turn into so they're going to turn into ketones. And then you have a tertiary alcohol that would be 3 carbon chains and it's got an OH group. Anyway, so the tertiary alcohol is not going to get oxidized. The primary one will turn into, so we're going to change all of that. We're going to change the carbon atom. And remember, it's everything. The changes would happen to the carbon atoms. The 3 orange dots, that's where the changes would happen. So the product of this oxidation, and let's assume that it's a complete oxidation. The primary one will turn into carboxylic acid. So this one over here will turn into double bond O and OH. That's the primary one. I did it on the wrong one. Just a second. Let me just redo this quickly. Anyways, this is in which the primary one. So this one. So the primary one, this orange one will turn into a carboxylic acid, so it would become double bond O and OH. The tertiary alcohols, this one over here, the tertiary alcohol, nothing would happen to it. The tertiary alcohol, it's not going to get oxidized. The secondary alcohol, ignore the OH, remove the OH, it will turn into a ketone, and there's going to be an oxygen. So that is going to be your product. So nothing happens to the tertiary alcohol, and that's your reaction. Is that clear? Muni, is this clear?
Yes, sir. Thank you.
Okay, so you've got so remember this, you need to identify which alcohol is which one. Let me just do one more example. If I have this molecule and there's an OH over here and there's an OH over here as well. So Maria, which one is this one? Primary, secondary, or tertiary? This one over here.
Primary.
That one is primary. Anything that would happen, it would turn into a carboxylic acid. And this one over here is what? The other one.
That looks like the secondary.
So that one is secondary. So anyways, you've got primary and you've got secondary, and what will happen is all the changes would happen to those carbon atoms, the one that I've marked. This one would turn into a carboxylic acid. It would become double bond O and OH. Again, I'm doing it on the wrong one. This one would over here turn into into a ketone. So let me draw the arrow the other way. So that's basically oxidation happening. So that is the oxidation of primary alcohol, secondary and tertiary alcohols, which you've already studied in AS. But again, that's very important in A2 as well. Now, there's another thing about this reaction, and that is that what if I want to stop the reaction at aldehyde? Like if I have a primary alcohol and I don't want it to get oxidized to a carboxylic acid, it will get oxidized to carboxylic acid if you use reflux. But what if I want to stop it at an aldehyde? So what you're going to do is, if you want to stop this reaction at an aldehyde, you would have to change the conditions a bit. So if you want to stop at aldehydes, use distillation instead of reflux. And you don't want it to turn into a carboxylic acid. So use distillation instead of reflux. I mean, the conditions that are used over here as reflux. The thing with reflux is nothing can get out of the container. Like reflux is this thing or heat with reflux, that's the proper word. So reflux heating is probably this one. So reflux is this diagram over here. So basically what happens is that there's nothing can get out of a reflux. You're heating it, you heat volatile substance when you're trying to reflux things. Volatile substances, they tend to evaporate, but there's a condenser on top. There's cold water in, water out, there's cold water coming in. That's cooling things down at the top. So any vapor that's formed at this point, if it tries to escape, it won't be able to escape, it will fall back into the container. So the reaction will continue. The primary alcohols will turn into aldehydes, and the aldehydes will turn into carboxylic acids. And nothing would come out of the container because they can't escape. But on the other hand, if you use distillation, what will happen is in distillation, the substances can actually escape, like this one. So distillation, the substances can actually escape because there's no condenser on the top. The condenser is over here. So as soon as the primary alcohols they turn into aldehydes, the aldehyde would evaporate, and you can remove it from the mixture, and the reaction would immediately stop because the aldehydes would escape the container. And the reason the aldehydes will escape is the aldehydes don't form hydrogen bonds. The alcohols have OH. The carboxylic acids have OH, so they have slightly higher boiling points. But aldehydes, they don't have an O bonded to an H, which is why it's just a polar molecule. Its melting and boiling points are slightly lower. So aldehydes very quickly evaporate. They're more volatile compared to the other two. So they would evaporate very, very quickly. As soon as they're formed, they would evaporate. They would leave the container and you can collect them at the other end. And the reaction would stop immediately because they're going to leave the container. They would evaporate. So to stop at aldehydes, use distillation instead of reflux. Is that clear?
Yes, sir.
Yes, sir.
So use and they might ask you for the reasons as well related to intermolecular forces. So you can state that aldehydes are more volatile, as they don't form hydrogen bonds. As they don't form that would be your reasoning compared to the other ones. Like the other ones are forming hydrogen bonds. So aldehydes tend to be more volatile. They escape the container very quickly. But reflux, nothing can come out. So it would eventually form carboxylic acids. Now, the other thing about about this particular process is that you can reverse it. You can actually turn it the other way around. You can reduce it. So let's talk about. We did oxidation of alcohols. Now we're going to talk about the reverse, the exact reverse. So you can do the opposite, which is reduction. So in reduction, it's the exact opposite. So reduction, I'll just write reduction of all of the above. So if you have a carboxylic acid, that carboxylic acid, it can be turned into, so that particular carboxylic acid can be turned back into an aldehyde. And that aldehyde could be turned back into
Primary alcohol.
primary alcohol, yes. So everything can be reversed by reduction. And the same with ketones. The ketones can be turned, so they can be turned back into secondary alcohols. And since tertiary alcohols never got oxidized in the first place, so there is no reduction for them. What do you use, if you remember, what is used for reduction? I mean, you need a reducing agent, but doesn't even remember what the reducing agent is. Sahib, any idea? Sam? Umar, Hamza? What reducing agent? There were two reducing agents. To reduce carboxylic acids, you had lithium hydridoaluminate or LiAlH4. So this one is lithium hydridoaluminate. It's actually got several names. It's this is one of the names. I mean, there would be other names which are also frequently used. I mean, we can just this is LiAlH4. So we can this one. Lithium aluminum hydride is also used. Hydridoaluminate is used. So it's got a couple of names. You can also use this one. Lithium aluminum hydride. And so LiAlH4 is a good reducing agent. And the same goes for the same reducing agents are used, but over here you can use a slightly weaker reducing agent, which is NaBH4, which is sodium hydridoborate or sodium boron hydride. So You can use LiAH4, or you can use NaBH4 as well. And the same over here, you can use LiAH4 or NaBH4. These are your two reducing agents for this reduction specifically. And that's about it. So when you see this molecule, all you have to do is whenever you see, let's do an example of reduction. So whenever you see a molecule, reducing carboxylic acids is slightly difficult, so which is why you use a slightly more powerful reducing agents. The other ones, both of them work. But for the first one, carboxylic acid, only LiH4, so one of them works, not both of them. So let's say I have a molecule. All you have to do is you have to turn it back into an alcohol. Like if I have a carboxylic acid group, it's got double bond O and OH, and there's another double bond. There's another double bond O. So if I have a carboxylic acid group, this one is a ketone. So what will a ketone turn back into? That's given above. It's going to turn back into a secondary alcohol. If I have a carboxylic acid group, it's going to turn back into a primary alcohol. But you don't have to worry about whether it's a secondary alcohol or primary alcohol. Just turn it back into an alcohol. It will automatically be the right type of alcohol. Like if I do this, if I take this molecule, and again focus on these carbon atoms, the ones that were forming the carboxylic acid, that were forming the ketone. So you're going to just focus on those particular carbon atoms. Just turn them back into an alcohol. Don't worry whether it's primary or secondary. It doesn't really matter. You'll always get the right type of. So you got an OH. This one will have an OH. So this one is automatically a primary alcohol. You don't have to worry about that. The carbon chain is bonded to just one. On one side, it's bonded to a carbon chain. This other one is automatically a secondary alcohol. So don't worry about what type of alcohol is going to be formed. Just turn them back into OH groups. So is this clear?
Yes, sir. Thank you.
Okay, so turn them back into alcohols. So we're done with two types of oxidations that you commonly studied in your AS chemistry. That was oxidation and reduction. One of them was alkenes, oxidation, strong and mild oxidation. The other one was were your alcohols, their oxidation, and at the same time their reduction as well. So we're now going to move towards what is required in A2. Now in A2, the first, so that is all that you studied previously as well. Now in A2 redox reactions, the first one is the oxidation of amines. So what happens in that case? I say in oxidation of arenes, what happens is arene. What is an arene? An arene is a benzene. It's basically a benzene, but with a carbon chain. The oxidation reaction is pretty simple. It's a benzene that has a carbon chain. So, and it could be any carbon chain, any sort of carbon chain, like CH2, and CH3. So there's a carbon chain that's attached. That's what an arene looks like. When you oxidize it, when you heat it with KMnO4, and remember it's going to be KMnO4, not K2Cr2O7. So when you do that, KMnO4 acidified and reflux. What happens is, no matter what the carbon chain is, doesn't really matter, whatever the carbon chain is, what you're going to do is, the reaction is pretty simple. Whatever the carbon chain is, just draw the molecule again, just get rid of the carbon chain. no matter how many carbon chains it's got, simply get rid of the entire carbon chain. We don't care what happens to it. Just replace it with a carboxylic acid group. It turns into a carboxylic acid. It gives you benzoic acid. That's about it. So if a molecule has, if there's another molecule that's got, let's say, 3 carbon chains, and you do the same thing to that molecule. Let's say here's another molecule, and this one is an arene. It's a benzene with carbon chains. And let's say there are 2 carbon chains. There's a CH3 carbon chain over here, and there's another one. So there's this other one over here. There's an ethyl group on this side. You do the same oxidation, KMnO4 acidified in reflux. So just get rid of the carbon chains, no matter how many of them, and replace them with carboxylic acid. That's about it. So you take this molecule, and the only thing you need to do is just replace, get rid of the carbon chains, and in their place, you're going to have a carboxylic acid group. So that's about it. So it's a simple reaction. Is that clear?
Yes, thank you.
Okay. Zaib, is this clear? Alicia? Zaib, is this clear?
Yes, sir.
Yes, sir.
Okay, so that's the first one, acidified in reflux. So remember this. So then the next one is, the next redox reactions that you're going to do is going to be related to, it's mostly reduction actually. So the next one is, so we're done with the arenes and their oxidation. Now the next one is the reduction of nitrobenzene. So reduction of nitrobenzene. What happens in this reaction is that if you have a nitrobenzene, what's a nitrobenzene? It's basically this thing. Just 1 second. It's a benzene with NO2 groups. Let's say it has one. So let's say it has one NO2 group. I'm going to remove this. So it's a benzene that's got an NO2 group. And I'm going to reduce it. So the conditions that are used for that are 10 plus concentrated HCl. And the NO2 group will turn into an NH2 group. That's about it. So its oxygens would be lost, and they would be replaced by hydrogens. And it will turn into an amine. So hydrogens added, H added, O lost. And the oxygen is lost. So that's about it. And so whenever you see a nitrobenzene, this is going to be the reduction of nitrobenzene. And it's benzene it turns into benzene with NH2. Is this clear? Is this clear?
Yes, sir. Thank you.
Okay, so just
Yes,
once.
sir.
So just a second, and it's there's some minor other reactions as well. The syllabus, the updated version, just a second. So 1 second. Let me just double check if they haven't been removed. So this is learning recall, that's alcohols, not. So we did that, aldehydes and ketones with NABH and carboxylic acid. So we did that. Reduction of aldehydes, we did that. Yep, we did that. So this one is reduction of amides with LiH4, reduction of nitriles with LiH4. Okay, we'll do that. The other two reductions are nitrogen compound related reduction of nitrobenzene. The next one would be reduction of, that's still in our course. So that next one is the reduction of amides. So the first question is, what's an amide? An amide is, if you remember polyamides, you did polyamides, nylon, etc. in O levels as well. An amide is this group. It's C double bond O and NH. So it's this group, and that's the rest of the molecules. That's basically what an amide is. So if I have an amide, it's let's say I have CH3, and there's a C double bond O, an amide or peptide link. You get that this is the same link that is present in your proteins as well. So I've got a CH2 and a CH3. And here's the molecule. So I'm going to reduce it with LiH4. So everything kind of remains the same except for the middle part. That when we use LiH4 for this, the oxygen over here is going to go away. It's going to lose its oxygen, and in its place, hydrogens are going to get added. So that's reduction of amides. Oxygen is lost, hydrogen is gained, and it's LiAlH4 that's used for that. That's your reagent. Oxygen lost, and two hydrogens are gained. And your amide turns into an amine. So this is an amide. While this one is just a plain amine. Amines, the difference between amines and amides are that we did amides when we were talking about strong bases and weak bases as well. So amides are, there's N, H, and the next thing that's around it is close to it, that's C double bond O. But in amines, you just have N with hydrogens, that's it. There is no C double bond O. There's just carbon chains around it. So that's what an amine is. Is that clear as well, this one? Munir, is this clear? Simon, is this clear?
Yes, sir.
Yes, sir. Thank you.
And finally, the last one is the reduction of nitriles. That's another one. So reduction of, so I'm grouping them together is because when you have a redox question, it's everything kind of comes, it all gets mixed up. So it's better to study all of this together. I've grouped things together which are where the questions would be very similar, and they would use all sorts of. So oxidation reduction questions a molecule will have multiple groups, so you would have to deal with multiple groups at the same time when you're doing questions. So reduction of nitriles. Now, what's a nitrile? A nitrile is it's RC. I mean, it's this group. It's CN, C triple bond. It's C triple bond N. So I've got a nitrile. And when you reduce it, the two, you can either use LiAlH4, or you can also use nickel plus H2 gas. That's nickel catalyst plus H2 gas. That's basically hydrogenation plus H2, this one. We can use that as well. And the same thing, hydrogens are going to get added to this. H is going to get added. So you've got R, CH3, C triple bond N. This is what's going to happen. You'll have CH3. The triple bond will go away. And hydrogens are going to get added to both carbon and nitrogen. So Just like in addition reaction, things get added to it. Just like alkene hydrogenation, it's similar. So this one is kind of similar as well. So the CN, I mean, this thing over here, the CN, it turns, it's still CN, except with more hydrogens. So it's still kind of the same thing, but hydrogens are getting added to it. So is that clear? This one?
Yes, sir.
Yes, sir.
So you have to remember about this one. One of them, like reduction of nitrobenzene, that makes phenylamine. I mean, this is a different type of amine. This one is known as phenylamine, the one that's next to benzene. While the other ones, these two, they make normal amines. Normal amines are the ones that just have a carbon chain. So let's go back. I think, are we missing any other redox reaction? Reduction. One second. I mean, we did this. We did the CO group in amides. We did that as well. The rest is just. Let's just go through oxidation as well. What's that's electrochemistry. Just want that. Not reactions. This one. So oxidation to form diol, we did the oxidation by that's about alkenes. Hot concentrate camenophore with the alkene linkages, the double bond would break. And with or acidified camenophore, that's carboxylic acid. We did the distillation part as well, so we covered everything. State the distinguishing reaction between color changes. We did the color changes as well. What else? Aldehyding ketones. We did all of that. Carboxylic acids. Need oxidation of primary. That's we did that. So that is no longer, I think, in your course. Just a second. Any other oxidation reaction? Color change, done. So I think, so they've actually removed the carboxylic acid oxidation. Just let me double check that if we. So carboxylic acids, no, there is, it's still there. These two. So you have to remember methanoic acid and oxalic acid, which is ethane dioic acid. They both turn into carbon dioxide and water. So camenophore, the other one is methanoic acid is this one. So they're two carboxylic acids that do get oxidized. So where's the, so we're going to add this over here. And remember, there's just two carboxylic acids. Not all carboxylic acids. There's methanoic acid and there's oxalic acid. So we just need to add that. That's the only thing that's missing. Otherwise, our redox reactions would be complete. So I'll just add it over here. That when you make carboxylic acids, only two carboxylic acids. The other ones are kind of resistant to oxidation. So only two carboxylic acids, they get oxidized. One of them is methanoic acid. Methanoic acid is this thing. It's HC double bond O. So it's got only one carbon atom. And it will get oxidized by tolerance reagent. It's silver. So AgNH3 twice. So that's tolerance reagent. That silver ions dissolved in ammonia. And they'll turn into carbon dioxide and water. And the other one is oxalic acid. That's this one is methanoic acid. And the other one is the oxalic acid or ethane dioic acid, which is, it's a double carboxylic acid. It's got a double bond ONOH on this side. It's got a double bond ONOH on the other side as well. You oxidize it. This one requires KMnO4 and reflux. So acidified KMnO4, H plus ions, and there's going to be reflux, heat with reflux, and it will turn into carbon dioxide. It's going to produce carbon dioxide. So two acids will be oxidized, two of them. So one of them is this one, the other one is this one, just two of them. And let me write the name of this one. This is ethane. So this one is ethane. I mean, the proper name is ethane dioic acid or diethanoic acid. Also known as, even in the questions, it's a very often it's referred to as oxalic acid. So that's about it. That, I think, sums up all redox reactions. So I'm going to share this with you, and so I'll just quickly go over that. I told you that there are lots of reactions that are redox reactions, but we were specifically interested. We're actually not interested in these reactions. Like chlorination, I told you was actually a redox reaction. But I told you I was specifically interested in those redox reactions where oxygens get added, or oxygen or hydrogens are added or removed. So we did the oxidation of alkenes, the mild oxidation, the strong oxidation where the double bond would break, resulting in multiple compounds. Then we did oxidation of alcohols. We did everything about primary, secondary, and tertiary alcohols. We talked about the two carboxylic acids getting oxidized. We did that as well. Then we talked about the reduction reaction, which was the exact opposite of the oxidation of alcohols. And then we talked about the oxidation of amines, that whenever you have a carbon chain, you add KMnO4. Whatever the carbon chain is, just get rid of it and replace it with a carboxylic acid. So that was pretty simple. Whenever you have NO2, you reduce it with 10 plus concentrated HCl, it turns into NH2. And then you had amides, you reduce it with LiLH4. The oxygen would be lost, replaced by hydrogens, and it's a redox reaction. You've got nitriles, and it will also get reduced. So that, I think, sums up all redox reactions for both AS and A2. Is that clear? This thing.
Yes, sir.
So I'll share. So we're done with the major parts of organic chemistry. We did, if you remember, we did electrophilic substitution. We discussed all types of electrophilic substitutions. We did hydrolysis of acyl chlorides of chlorine-related compounds. We did which acids were strong, which acids were weak, and we studied the whole of this redox, who's getting oxidized, who's getting reduced. So there's just minor reactions that are left, and we're going to go through those, especially nitrogen-related reactions. So we're going to go through those reactions. So I'll share all these PDFs, all three of them. Okay. Make sure you go through them, you revise them, and tomorrow we'll have a past paper class. I've shared the paper with you. Make sure you try and go through that paper yourself as well. Okay, so let's continue tomorrow.
All right. Sir, can you also send me the recordings?
लास्ट वाला या वही वाला नहीं भी एक सेकंड मैं फिर देख लूं कि मैं काम करता हूँ I'll share the photo with you. ठीक है
Okay.
उसमें ना ये करना कि what you should do is no video. ठीक है we must have. What you should do is if you download the folder now, then you should pretty file in this one. There's a conversion option somewhere. not this one. Okay. Now, if you open a no video or double click to convert, you would have to download it and then convert it. Okay. So I'll do something about this. Okay. You may share कर दो, photo ही share कर देता हूँ.
Alright, sir.
Okay. Love it.
Thank you, sir.
Take care.
Allah Hafiz. You too.